Hello, I'm Achut Nair from Nair's Aviation Ground School. This is the 22nd video in a new series of educational aviation videos for the aspiring pilot. In recent videos, we have discussed the importance of the engine, the fuel, and the controls of the aircraft. Putting all of this together, the engine startup and the before takeoff run-up ensures that the aircraft is fit for flight. This video is about the engine startup and run-up procedures. The engine is an essential ingredient in the recipe for flight. The engine startup process is required on all aircraft, no matter the size, power rating, or performance capability of the airplane. Many variations of the aircraft engine starting has been used since the Wright brothers made their first powered flight in 1903. The methods used have been designed for weight saving, simplicity of operation, and reliability. Early piston engines were started by hand, with geared hand starting, electrical, and cartridge operated systems for larger engines being developed over the years. Gas turbine aircraft engines, such as turbojets, turboshafts, and turbofans, often use air or pneumatic starting, with the use of bleed air from built-in auxiliary power units, APUs in short, or external air compressors, now seen as a common starting method. Often, only one engine needs to be started using the APU or remote compressor. After the first engine is started using APU bleed air, cross bleed air from the running engines can be used to start the remaining engines. The most common general aviation aircraft is the Cessna 172. The 172 will be the first training aircraft operated by the majority of student pilots around the world. Therefore, it is important to understand the startup procedure of the Cessna 172's engine. Starting the engine of an aircraft is more complex than the simple twist of a key or the push of a button needed to start cars on our roads. Aircraft engines are more complex and operate under different conditions than cars and require a more thorough startup procedure. Initially, the throttle of the Cessna 172 is pushed in a quarter of an inch. The mixture control is pulled to the idle setting, or basically pulled all the way out. Now, it is very important to make sure that there is nothing or nobody in front of the aircraft before starting the engine. As soon as the engine is started, the propeller will be spinning, so it is important to make sure that it will not hit anything or anybody. Therefore, the pilot needs to yell "clear" before the engine is started. The master switch is then turned on, providing electrical power to the engine, allowing the starter to be able to assist in starting the aircraft. Sometimes, if the engine is cold, it is important to prime the engine before starting it. This is accomplished by turning on the auxiliary fuel pump, pushing the mixture to full for 3 to 5 seconds, enough time to ensure that proper fuel flow is indicated on the instrument. Then, the mixture is pulled all the way back to idle again. The final step of the priming process is to turn off the auxiliary fuel pump. Priming the engine allows there to be some fuel in the lines, easing the starting process. After the engine is primed, if needed, the engine can be started. To do this, the key must be inserted into the keyhole and turned and held at the ignition position. The key can be released when the engine has started. This step is almost exactly the same as twisting the key to start a car. As the engine is starting, it is also important to push the mixture control to the full rich position. After the engine is started, the throttle should be pulled back to indicate around 1000 RPM or rotations per minute. This is how an engine in the Cessna 172 is started. After the engine start and the aircraft is taxied to the runway, one can often see aircraft doing their final checks before taking off. One of these final checks is the engine run-up. The checks performed during a run-up vary with the type of aircraft and to a lesser extent with the operating rules under which the flight is being conducted, for example under instrument flight rules or visual flight rules. The term run-up alludes to engine checks that involve temporarily advancing the throttles to ensure that engines are capable of producing takeoff thrust, although not all run-up procedures involve such checks. A run-up area is a location at an airport where pilots can perform run-up checks of their aircraft. They exist because air blasts from engine verification may cause problems for other aircraft or structures, and so a special area where such checks will do no harm is set aside for them. They also allow aircraft to temporarily leave taxiways so that they don't obstruct ground traffic while the run-up is performed. For these reasons, run-up areas are typically located near runways. The run-up is usually the last step before moving into the runway and starting the roll for takeoff. The engine start procedure is a crucial step in the process of flying an aircraft. Engine starting can be simple or complex, depending on the aircraft and the conditions, but it is important to keep in mind that the safety consciousness that is required to ensure that all aircraft are in good shape before any flight. This is also why we do a run-up during the final moments before taking off. The engine startup technique and the run-up not only ensure that the engines are working, but add to the safety of aviation overall. For more information, please contact us at liftanddrag@gmail.com and visit our website at nyersaviation.webnode.com. Thank you, safe flying.